Welcome to the deep dive. We're plunging into a stack of your sources to cut through the noise, literally and figuratively today.
That's right.
We're zooming in on the intense, tiny world of high-performance radio-controlled vehicles. You know, the ones that just scream.
Yeah, absolutely. Intense is the word.
So if you've ever had an RC car, like twitch or glitch, or maybe even crash for what seems like no reason,
Happens all the time.
our mission today is to demystify this crucial little component that tackles a hidden culprit, electrical interference. We want to give you a shortcut to understanding why it's so important, for keeping your RC car actually doing what you tell it to.
It's true. It looks simple, this little ring, but it's actually a cornerstone of power electronics, really. It's specifically engineered for the incredibly demanding environment inside an RC vehicle.
Yeah.
High energy, lots going on.
A silent guardian, you could say.
Exactly. The silent guardian ensuring your fun doesn't, literally come crashing down.
Okay, so we're battling electrical chaos here. What's the frontline soldier? People often call it a ferrite ring or maybe a ferrite choke, but our sources say it's something a bit more specific.
Precisely. It's technically known as a toroidal inductor.
Yeah.
Just think of it like a wire, usually copper, wrapped around a donut-shaped magnetic core.
A donut, okay.
Yeah, and in RC, that core is almost always ferrite material. Its main job. Store energy in a magnetic field, and, this is the key part, resist changes in electrical current. It kind of smooths things out.
So it pushes back against those sudden electrical surges that can make your car go haywire.
Exactly. It dampens that electrical violence.
But the real magic, apparently, is that toroidal shape, that donut shape. It's not just for looks.
Oh, definitely not. That shape is all about efficiency. It's engineered so almost all the magnetic field lines stay inside the core. We call it low leakage flux. Think of it like it traps the magnetic field, preventing it from radiating outwards and messing with your radio signal or other electronics.
So it keeps the interference contained.
Right. And for its size, it's way more efficient, compact, and lighter than other shapes. Which, in an RC car, every gram matters.
That makes sense. Super compact. So why do RC cars specifically need this? They seem, fairly simple on the surface.
Well, the thing is, the modern RC environment is incredibly noisy, electrically speaking.
Noisy? How so?
The biggest offender is usually the electronic speed controller, the ESC. It switches really high currents, we're talking over 100 amps sometimes, very, very quickly to control the motor speed.
Wow. 100 amps is a lot in something so small.
It really is.
Yeah.
And that rapid switching creates this huge burst of broadband electrical noise, like a tiny electrical storm inside the car.
Okay, I'm picturing that now, like static.
Kind of, but much more disruptive.
Yeah.
You can travel through the wires that's conducted EMI or radiate out through the air-radiated EMI. And other things contribute too, like high-torque servos. Even just long battery wires can act like antennas sometimes.
Huh. So it's an invisible storm messing things up. I swear my truck did a random backflip once. I bet that was it.
Could well have been. But this brings up a really important point. Not all glitches look the same, and they aren't all caused by noise.
Okay.
That toroidal inductor, the ferrite ring, it's a noise filter. Its job is cleaning up that high-frequency electrical static or EMI. But sometimes your car might act weird because of a brownout.
A brownout, like in a house?
Sort of. It's a power stability issue. The voltage momentarily dips because something, usually the servo or motor, draws a ton of current all at once. Your receiver basically resets.
So the lights flicker, metaphorically speaking.
Exactly. And for that problem, you need a capacitor, often sold as a glitch buster or BEC capacitor. It provides a little reserve power for those dips.
So inductor for noise, capacitor for power dips, they're not interchangeable?
Absolutely not. You got to diagnose the problem correctly. Is it noise interference or is the power supply just sagging?
Yeah.
Very different fixes.
That's a huge takeaway. Okay, so back to the toroidal inductor, the ferrite ring. How is it actually used? Where does this little donut go?
Typically, in RC, you'll see it wrapped around the signal wire that connects the ESC to the radio receiver.
The thin little 3-wire cable?
Usually, yeah.
Why?
It acts as what's called a common mode choke. That means it blocks noise that's traveling equally on all the wires in that cable, like a background hum that affects everything.
Okay.
But it lets the actual control signal, the steering command, the throttle command, pass through just fine because that signal is differential. It's different between the wires.
So it cleans the line, basically. Lets the important message through, blocks the garbage.
You got it. purifies the signal path.
Now, I know modern radio systems like 2.4 gigahertz are pretty good at resisting interference compared to the old AM/FM stuff.
They are much better.
But you're saying the power levels in today's cars are way, way higher. Brushless motors, LiPo batteries.
Exactly. So even though the radios are more resilient, the amount of noise being generated inside the car has exploded. It's far more intense EMI.
So the ferrite ring hasn't gone away, it's just become more of a strategic tool.
That's a good way to put it. It's maybe not needed on every single setup like it arguably was years ago, but it's especially critical in, say, ground vehicles, high-performance buggies, monster trucks.
Why them specifically?
Well, think about it. Components are crammed really close together. Chassis are often metal or carbon fiber, which can actually help conduct noise around.
Yeah.
And the power systems are just pushed to the absolute limit. It's the perfect storm for EMI problems.
Right. Everything's packed tight, lots of metal, tons of power.
Precisely.
And the cost benefit seems like a no-brainer. Our sources say these things cost, what, less than $1? Weigh almost nothing.
Yeah, pennies, basically. And maybe a gram. It's incredibly cheap insurance compared to a high-speed crash because your signal glitched out.
Totally. So, highly recommended, especially if you're running a high-power, brushless system. And I think I read you often wrap the wire through the core multiple times.
You do. Each wrap increases the inductance, making it more effective at blocking that noise. 2 or 3 turns is common.
Got it. But it's not a magic bullet, right? It's part of a bigger picture.
Definitely. A toroidal inductor is powerful, but it's really part of a holistic approach. You know, good build practices matter just as much.
Like what?
Like physically separating sensitive stuff, like the receiver, from noisy stuff, like the ESC and motor, as much as possible. Careful wire routing is huge. Keep wires short. Try to cross power and signal wires at 90 degrees instead of running them parallel. Twisting the main battery and motor wires together can also help cancel out some magnetic fields.
Simple stuff, but makes a difference.
A big difference. And of course, using high-quality components, good ESCs, reliable BECs, or receiver batteries, that helps prevent problems in the first place. The ferrite ring is kind of like that crucial final line of defense, especially when you're really pushing the limits.
Okay, so wrapping this up, what does this all mean for you listening, whether you're a serious racer or just love bashing around the backyard?
Well, I think understanding what this little toroidal inductor, this ferrite ring, actually does is really empowering. It helps you diagnose problems better, right? You can stop guessing. It helps prevent potentially costly damage from glitches, and it lets you really engineer a more reliable, high-performance RC system that actually, responds exactly when and how you want it to.
Building confidence in your gear.
Exactly.
Okay.
And while maybe future electronics will have more filtering built right onto the circuit boards,
yeah, maybe someday,
the basic principles of electromagnetic interference, EMI, and how you deal with it, those are going to remain essential knowledge for anyone really pushing the boundaries of RC performance.
So the next time you see one of those tiny black donut rings on an ESC wire, you'll know it's not just decoration. Yeah. It's a silent guardian, working hard to keep those control signals clean and making sure your vehicle stays exactly where you point it, hopefully screaming across the track, not flipping into a fence.
Let's hope not.